Hey, fellow mathers. Before we get into this episode, we want to share with you how you can get access to free content, professional learning that will keep your students engaged and doing the math that matters. Get ready to go to this link, mathisfigureoutable.com/challenge.
That's right. Registration is open for the free Math is Figureoutable challenge that's starting May 15th and runs to the 17th at 7 p.m. Central. We're going to have 3 nights jam packed with learning and routines that you can take straight to your classroom.
In these challenges, we have a great time. We do some math, talk about classroom experiences, give away super cool bonuses and prizes. You won't just walk away with routines that are naturally engaging and encourage your students to think mathematically. You'll also have a chance to win over 6K worth in prizes, including a few virtual PD sessions for your school. I'll be joined by my wonderful co-host Kim and special guest Jenna Labe.
You can register at mathisfigureoutable.com/challenge for a fantastic learning experience. That's mathisfigureoutable.com/challenge. Now on to the show.
Hey, fellow mathematicians, welcome to the podcast where math is figureoutable. I'm Pam.
And I'm Kim.
And you found a place where math is not about memorizing and mimicking, waiting to be told or shown what to do, but it's about making sense of problems, noticing patterns, and reasoning using mathematical relationships. We can mentor mathematicians as we co-create meaning together. Not only are algorithms not particularly helpful in teaching mathematics, but rotely repeating steps actually keep students from being the mathematicians they can be.
So this episode is all about a really cool connection between proportional reasoning and functional reasoning that may surprise you. So Pam, let's start off. And if I can, I'm going to tell you a little bit about my experience. I know that we've talked about my mathematics before, and in elementary school and middle school and just all through proportional reasoning, I really was able to make sense of things, even though my teachers weren't teaching me in a way that was really figure outable. It was for me. It was very rote, memorized practice. And that was fine for me, with me, because I didn't know any different as a teaching practice. And I was okay until about pre-cal. I hit a wall in pre-cal, to be perfectly honest with you. I, at that point, felt like I couldn't figure anything out anymore. And I still, because I had some memorization skills, I still did okay, but it fell apart in my mind. I thought for sure I had reached a point where it either made sense to you or didn't, and it wasn't going to make sense to me. And so I just shied away at that point and said, I don't get it anymore. This isn't for me. And I was really interested in math, and I really loved my math classes. And I just didn't at that point. It made me sad.
And it makes me sad hearing you talk about it. But I hear you saying at that point, math became not figureoutable anymore. It's almost
absolutely.
it's almost like in your head, the nature of math changed.
Yeah.
You're like, oh, this isn't fun anymore because it's not figureoutable anymore.
Yep.
Now it's just a bunch of formulas to memorize, and I can do that, but that's not fun.
Yeah.
That's interesting. Is there a point where math is not figureoutable anymore? Is there some, like you might be thinking, teachers, well, it's figureoutable until you have to do long division. You can't really, long division, you just got to do the steps. Or is division figureoutable? You might be thinking, well, it's figureoutable until it's division of fractions. Then you just have to invert and multiply. We don't know why. Or is it figureoutable? Do you think that there's some juncture where we really just have to do the formulas? Or is math always figureoutable? So we thought we'd take today and do a little bit of some high school stuff to illustrate a bridge that we might be able to sort of take you from some things that and help you see this bridge to maybe something that you thought was kind of only rote memorizable, but it is actually pretty figureoutable. So we're going to have a little bit of fun today. One of the things that I want to do is mention that we do this wonderful work, and we've done it in the podcast. We definitely do it in Building Powerful Multiplication, our online workshop, and the online workshop called Building Powerful Division, and in our online workshop called Building Powerful Proportional Reasoning, where we work with ratio tables multiplicatively.
Mm-hmm.
And I want to build this bridge from what we could do in ratio tables to multiply, to divide, to solving proportions, and to reasoning proportionally and doing great things in ratio tables. And I want to paint this bridge of how we can then use that in an algebra class in a way that you might have not thought about. So consider, if you've never done any work in a ratio table, you might want to go back to at least one episode where we do some multiplication or division in a ratio table. But consider that if you've done some work in a ratio table, then you will probably recognize relationships like this. So Kim, I'm just going to throw some numbers out to you.
Okay.
And I want you to tell me kind of everything you're thinking about. And yeah, here we go. If I were drawing it on a board right now, I would be putting in a ratio table. So I'm going to say 1, 6, and I would put 1 on one side of the ratio table and 6 is sort of the output. So the input's 1, the output's 6.
Okay.
2, 12. It's kind of like I'm giving you ordered pairs, right?
Yeah.
2, comma,
Okay.
12.
Yep.
3, 18. 4, 24. What do you notice? What are you thinking about?
So a couple of things. It's going up by 6s in the output, but I think more importantly, the relationship is that it's from one side of the ratio table to the other, from I guess the X to the Y, is times 6 in each of those entries.
So if I were to say, if you'd graph those points, what would they look like? Like, is there a pattern? Is there no pattern? They'd be random all over the place.
No. It's definitely a proportional relationship.
Okay, so it'd be a line. It'd be linear.
Yeah.
And in fact,
and it's going to go up because it's increasing.
Okay, increasing. Nice. And you said it was a proportional relationship, so you also know it goes through 0, 0. Okay. You could probably, if I pushed you, you could put a context to that. I bet you could think about.
I like packs of gum. So
1 pack of gum
or Jellos. Oh, my kids love these Jellos that come in a 6-pack.
Okay, nice. Yeah. All right, cool. Or 6-pack of soda, maybe. Well, like whatever. So it could kind of represent all that. And what if I said that if I plotted all those points and I connected them with a line, could you write the equation of that line?
Sure.
How do all the y's relate to all the x's?
Yeah. So y is x times 6. Or I guess you would say y equals 6x.
Yeah, so by convention, we usually write the coefficient first. Yeah, but I like that all the x's times 6. I like that a lot. And I would totally, if a student said that to me, I would literally write y. And as you said, I would say all the y's. And then you said equal. I would write equal. And then you said x. And I would write x times 6. All the x's, I would write x times 6. And so I would literally write y equals x times 6. And then I would say, oh yeah, and by convention, we usually write that as y equals 6x. So I would sort of represent your thinking, and then I would write it equivalent to the convention that we usually write. Cool. Okay. So then, Kim, what if I said, well, here's a new set of points. Maybe there's a special on the Jello. Oh, okay. And so Jellos, do you put an S on Jellos? I don't even. Okay.
Jello cups. I don't know.
No, better. Yeah, that makes it.
New ratio table.
I don't know. Okay. New ratio table. So 1, 7, 2, 13, 3, 19, 4, 25. And I'm kind of curious what you see now. And really, I'm heading towards writing the equation.
Okay. I actually really like that you said something about the context. Because some of the numbers seem kind of random, except when I look back at the y's in the problem you just gave me. Yeah. There each time is one more. So it's that same 6x, but it's plus 1 this time. So y equals 6x plus 1. Nice. It's almost like, if you look at that second ratio table, the 7, 13, 19, 25, it's almost like if you kind of cross your eyes and sort of look double or something, kind of like I picture. I think I know where you're going. Yeah. What just happened in your brain when I said that? Well, so that same line, I don't know what you call it. Same line is shifted up 1. It's just shifted up 1. We've just taken that line. It's almost like I should just get 1 Jello cup for free. Bam! That's exactly what it is. It's like bonus. Yeah. In bonus. Context, today you get one. Yeah, you get one more Jello cup. Nice. So we have a colleague. Her name is Ann Roman. Ann, how you doing? Ann. I know, right? Who one day, after she was a 5th grade teacher at the time, she since went on to work with the Dana Center, do some amazing work. At the time she was teaching 5th grade, taught me a lot. We worked together a lot. And she was doing so much work with multiplication and division with ratio tables. And then she went on and was doing some graduate work, and she was taking a class, and they had to write the equation of a line to match data. And she said to me, Pam, I'm looking at these tables of values that I'm supposed to do all this like crazy formula work, but I just sort of,
it's almost like I'm looking at an optical illusion where it's the old woman and the young woman. And if you kind of close one eye and tip your head, you sort of see the young woman. And if you kind of open your eye and tip your head the other way, you see the old woman. They kind of, one comes in focus and the other comes in focus. She said, I look at these tables, and if I kind of just I see a ratio table shifted. Like I can just picture I've done so much work with the ratio tables. I just see the ratio tables like screaming at me, but it's just been shifted. And so I just write down the equation for the ratio table, and then I just shift it. Can I do that?
Yeah.
Y'all, I was floored. I was just like, that is amazing thinking. And now I see it. Now I see tables of values, and I just look to see if I can see the shift. So let's practice that a little bit. Let me just see if I can give you some tables of values, maybe without the original ratio table this time, and see if you can like tip your head, close one eye.
Okay.
Yeah. And see if you can picture the original, and then we can write the equation line from there.
Okay.
So what if I gave you something like 1, 6, 2, 11, 3, 16, 4, 21. And I'm just going to suggest that if you're listening to the podcast, you might write those down, pause the podcast and look at those and see if you can kind of feel a ratio table around there. So 1, 6, 2, 11, 3, 16, 4, 21, pause. All right, Kim, what are you thinking about?
So I was looking at how could I get from X to Y?
Yeah.
And so I was thinking about what is around 6, 11, 16, 21. And I noticed that it is going to be 5 times X, and then just shift up 1. So Y equals 5X plus 1.
Because if that 6, 11, 16, 21 is so close to 5, 10, 15, 20.
Yep.
And how close? Just 1. They're just one. Bam.
Nice.
So it's really important that the X's are this arithmetic sequence, that they're just upping by 1. That's actually important. And I have to say that because I know I have secondary teachers right now that are like, you can't just look at the Y's. And I know that. But my suggestion is, if students have been dealing with ratio tables a lot, they've already taken that into consideration before they look for a pattern in the Y's. They're taking the X's into consideration because they've had to in ratio tables, because the work in ratio tables has not been in order. In fact, for me, giving these points in order is almost like, whoa, they're in order. Huh, how interesting. How droll. How immature of you that you have to have them in order, because they're so used to having to order them. They're so used to having them out of order in a way that makes sense for them to use, that's useful for them, that it's almost odd that they're in order. Not in a bad way, in a, well, that's easy. Okay. It's like almost in a, well, I guess if you have to be that easy kind of way.
Right.
All right. So let's try another one if you're ready. You ready for
Okay.
that? All right. Here we go. 1, 1, 2, 3, 3, 5, 4, 7. So pause the podcast. All right, Kim.
All
What are
right.
you thinking about?
Got it. So I think that it is Y equals, what was I going to say? 2X minus 1.
Okay, so I love the fact that you're giving me an answer, but I kind of hate the fact we're not hearing your thinking. No,
Okay,
I want to hear you.
So again, I was thinking about, it's a little bit like I see the pattern maybe a little bit quicker than I remember how to write it, like the social bit of writing it. So like once I figure out how to write it, then I get excited. Sorry.
Sure.
Okay. So
now that makes sense.
I'm thinking about, again, from X to Y, I wanted to know how do I get from 2 to 3? And at first I was like, could be times 1 plus 1, but then that doesn't work with 3 or 4. And then I was like, let me go over. So times 2 would be 4. Then how would I get to 3? Would just be minus 1. And then I kind of confirmed it with the 3X and the 4 as the X.
So I really like your strategy, and I would definitely bring out your strategy. I heard you really focus on how to get from X to Y, which is totally what is the functions are based on. There is a slightly separate, and I want to build your strategy.
Yeah.
So I definitely want that, and I'm glad it's coming out. But if I was doing this with multiple students, I would expect that there would also be a different strategy that would come out that I would want to highlight and then build both strategies in students. So I might wonder if I would look at 1, 3, 5, and 7 and wonder if I know multiples that are near those. So once I've established the 1, 2, 3, 4, so I have this sequence that's upping by 1 every time. Once I have
Mhm.
that on
Mhm.
the X's, then I can kind of I could choose to ignore the X's. You didn't, which is a great strategy. But I could also sort of look at 1, 3, 5, 7 and go, is that near a multiple I know? Well, I know 2, 4, 6, 8. Oh, but these are all just one less than that.
Mhm.
And I feel like that would be kind of an Anne Roman strategy. Like sort of feel the 2, 4, 6, 8, but it's all one less than that. Does that make sense?
Yeah. I'm not sure why you would go to 2468 or
It would literally only be if that one sort of pinged for you.
okay. All
And
right.
if it doesn't ping for you, then your
Yes.
strategy would be a great
Yeah.
almost more general one. Your
Yeah.
strategy is more general. It's going to be it's probably going to work. It's probably going to work more often. So the and strategy is only going to work if the multiples ping for you. I wonder if I have one that let's try another one.
Okay.
Okay, new one. Ready?
New post-it.
Here we
Okay.
go. You and your post-its. I love it. Oh,
Mm,
and are you writing with pen or pencil?
a pencil, of
And I've
course.
totally got a pen in my hand. I love it. Okay, here we go. Ready? 118,
Oh, okay.
235, 10, 171.
Whoa.
Oh, and then we're done. That's it.
Oh gosh. Oh
I
gosh.
just
Oh
had a
gosh.
thought I don't want to
Oh, you know
forget.
what? Okay, so this I really did see the 1735 170. That's not going to work. Oh, 1734 170. Sorry. Got excited about 35. So then that would definitely I would see the 1734 170 and know that it has something to do with 17, but then it's just shifted up one. So 17x plus 1. So
Yeah.
that one I did focus on the shift.
And I wrote it on purpose in a way. So when I write problem strings, right, if I'm aware that that strategy might not be coming out,
Yeah.
then this particular problem, I put that 10 in there.
Yeah. Well,
So
in times
yeah.
17, my strategy of going from X to Y, times 17 is not amazing. It's not
Doesn't pop as
not a
much. Doesn't
fun
pop as
thing.
much.
Yeah.
Yeah, interesting. Interesting.
Nice.
What do you think? Yeah.
Yeah, I like it.
So there can be this sense of if I have done a lot of ratio table work, those multiples might pop. And if they do, we can use them.
Yeah.
If they don't, then we could go more to the Kim strategy where I'm looking at the relationship between X and Y. And if that doesn't work, then I could do something a little bit more where I have to maybe find some differences and do some work to write the equation of the line. Um, but mathematizing is not about one way to do every problem.
Right.
Mathematizing is about using what you know, relationships and connections that ping for you. And if they ping for you, then going down that road. And Kim, you taught me that. That is so something you taught me. And y'all, we do stuff like this in my online workshops. And I'm so excited to debut Building Powerful Linear Functions, where we really help you think about how can we take students from really knowing nothing about writing the equation of a line to writing the equation of a line given any information from no rote memory. And we do it in a sequence of about 13 tasks, 13 to 15 tasks, depending on how long your class periods are. And we can help both you and your students learn more and more about linear functions and how they are actually really quite figure outable. Woo! So Building Powerful Linear Functions is now available. I am so proud to have it out there. High school teachers, your time has arrived. Sign up now so you don't miss out.
Yeah, head on over to mathisfigureoutable.com/workshop to book your spot. And you really do want to hurry because
Oh,
registration
sorry.
closes.
Workshops.
Oh,
Mathis.
okay.
mathisfigureoutable.com/workshops.
Okay. Head on over to mathisfigureoutable.com/workshops to book your spot. And you do want to hurry because registration closes this Friday.
Yeah, this Friday, y'all. We'd love to have you join us. Elementary, middle school teachers, remember, we also have a workshop for you. Building Powerful Addition for young learners for pre-K through second grade, Building Powerful Multiplication for third grade and up, Building Powerful Division for third grade and up, and Building Powerful Proportional Reasoning for sixth grade and up, though fifth grade teachers, you're really wanting to do that after you do multiplication division.
Yep.
And Building Powerful Linear Functions for eighth grade and Algebra 1, but anybody higher than that who's never really thought about how we can develop linear functions just from students' own experience and thinking. Y'all, we're so excited for the first time ever to have workshops K-12. Everyone in your district can get involved. We can really get figure-outable math happening all over the place.
And I'm going to say that one more time so I don't mess it up. You want to go to mathisfigureoutable.com/workshops to reserve your seat.
Y'all, thank you for tuning in and teaching more and more real math. To find out more about the Math is Figureoutable movement, visit mathisfigureoutable.com. Let's keep spreading the word that math is figureoutable. Thank you for listening and making math more figureoutable.
To learn even more, make sure you register for our free challenge at mathisfigureoutable.com/challenge. You are not going to want to miss the evenings of May 15th through 17th, starting at 7 p.m. Central.
Math teaching, go register now. That's mathisfigureoutable.com/challenge. Join us to make math more and more figureoutable. And if you can't join live, register and we'll send you access to the recordings. We'll see you there.